Hello, pre-calculus friends. You will be happy to know that I found a new joke for you. It's even better than the last one, and it goes like this. What did one math book say to the other math book? Leave me alone, I have enough of my own problems. See, that's a good one. Alright, so we're doing section 3-4 on inverse functions and relations. And we're going to take a quick notes. We are not going to finish this whole packet in the video, so we'll finish it in class tomorrow. But we're talking about inverse functions. Again, hopefully something you've seen before. It's a function that reverses another function. So a common example would be converting between Celsius and Fahrenheit. You have an equation C equals 5/9 F minus 32 to convert from Celsius to Fahrenheit. And to discover the other conversion in the alternate direction, all you would do is solve that equation for f, and you would have the inverse function. So two relations are inverses if and only if one relation contains the element yx when the other relation contains the element xy. So you're literally just switching your x and y values. To graph a function or a relation and its inverse, switch the x and y coordinate of the function. Essentially what you're doing is reflecting the graph over the line y equals x. Because if you remember when we talked about symmetry, reflecting over y equals x means you switched the x and y values. So here's a first example. We have a function f of x equals -1/2 absolute value of x plus 3 and its inverse. So we're first going to graph this function. The parent function is absolute value. The negative means we flip over the x-axis. The 1/2 changes our slope, and the plus 3 tells us we're going up 3 units. So my absolute value vertex is going to be up 3 units. My slope is going to be down 1 over 2, down 1 over 2, and I'm flipping across the x-axis, so I'm an upside down V. Then what I'm going to do is I'm going to take the line y equals x here, and I'm going to reflect all the points across that line, essentially just switching my x and y values, switching my independent and dependent variables. So this point right here, the point 0,3, is going to become the point 3,0. This point here will reflect onto itself. This point is the point 4,1. It will now be 1,4. This point here is -2,2. It'll now be 2, -2. So you can see my inverse function is going to look something like this. So if f of x is in green, our inverse function we denote with an f -1 of x. That is our inverse function. So all I've done is taken the original graph and reflected it over the line y equals x. So now, I would like you to pause the video and try and do this next one. I haven't given you any translations, just the graph of x squared, and I just want you to reflect it across the line y equals x. So pause the video and try that. So here I have the solution. The function f of x is in green, the line y equals x in pink, and blue shows you the inverse function. So it can be really helpful to plot specific points here using a table of values and reflecting those specific points across the line. Just like we have a vertical line test to determine if a function is if a graph is a function, we can also we have a horizontal line test to determine if the inverse of a function is a function. So I have two graphs here of functions. And when I do a horizontal line test, if the horizontal line hits the function more than once, then the inverse of that function is not a function. So for example, this first one, anywhere I draw a horizontal line, it's only going to hit the graph once. So the inverse of f of x is a function in this case. Whereas on the second example, when I draw horizontal lines, I hit the graph more than once. So the inverse of this function is not a function. So I can, to find an inverse of a function, I just want to switch the x and y values and solve for y, and then I can find the inverse. So for example, determine if the inverse of f of x is a function, and find its inverse, So here's my function. If I were to graph this is a parabola with a vertex that is down 5 units, 1, 2, 3, 4, 5, to the left 3 units here, and it's not rotated in any way, so I'm looking something like this. If I do a horizontal line test, the inverse is not a function. So first I want to graph the function and do the horizontal line test, and I've discovered that the inverse is not a function. The second step is to find the inverse by switching x and y and solving for y. So in my function, f of x is y, so I'm going to change that to x, and everywhere I see an x, I'm going to put a y. And then I'm just going to solve for y. So I'm going to move the 5 over. I'm going to take the square root of both sides. When I do that, on this side I get plus or minus root x plus 5 equals y plus 3. When I square root my squared, it just goes away. And then I'm going to subtract the 3 over. So I get y equals negative 3 plus or minus the square root of x plus 5, or f of negative 1 equals negative 3 plus or minus the square root of x plus 5. So this then is the inverse function to my function. So now I would like you to try one. Your function is x squared minus 4. First you want to graph it, determine if the inverse is a function, and then find the inverse. So pause the video and do that, and I'll give you the answers in a moment. This next example is pretty similar to things we've been doing already. You can use a parent graph of a function to find an inverse function. So for example, the graph square root x minus 1 plus 2, I can graph the parent function and then use that to find the inverse. So the parent function for this graph is y equals the square root of x. The inverse of this function, if I were to switch x and y and solve for y, would be y equals x squared. So this is the inverse, and this is the parent graph. So what I can do is to graph y equals root x, I can start with y equals x squared and then reflect it over y equals x, and then translate it. Translate it up to and to the right one. So first thing I'm going to do is graph y equals x squared. And when I do that, I get my parabola, plotting some points here. Okay, I'm going to reflect it across the line y equals x. A square root function can only be positive, so I'm only going to take those positive values. Okay, so there's the inverse in blue, and then I'm just going to do my translation. So I'm going to take each point, move them up 2 and to the right 1. So let's see, that'll look like up 2 to the right 1, 2 to the right 1, 2 to the right 1. So there in pink is the inverse function. Again, just repeating some processes we've done already. Okay, last example. Two functions, f and f of 1, are inverse functions if and only if, when you plug one into the other and then do the opposite operation, you should get the same thing. So you should always be able to plug an inverse into a function and end up with x, and you should always be able to plug a function into the inverse and end up with x. So let's see what that looks like. I have a function f of x equals 3x squared plus 7. And first I'm going to find its inverse, and then I'm going to verify the relationship. So to find the inverse, I'm going to change x and y. So x equals 3y squared plus 7. Solve for y. X minus 7 equals 3y squared. Divide by 3. X minus 7 over 3 equals y squared. And square root both sides. y equals plus or minus the square root of x minus 7 over 3. So my inverse function, I'm going to take the positive square root, x minus 7 over 3. So what I'm going to do is I'm now going to plug the inverse function into the function everywhere I see x. So that's going to look like 3 times the square root of x minus 7 over 3 squared plus 7. And then I'm going to plug the function into the inverse. So I'm going to take my inverse, square root, everywhere I see an x, I'm going to say 3x squared plus 7 minus 7 all over 3. And I'm going to solve these and see what I get. When I square a square root, my square root cancels. So this is 3 times x minus 7 over 3 plus 7. My 3's cancel. X minus 7 plus 7 is x. On this one here, underneath my square root, I have 3x squared plus 7 minus 7. That's the square root of 3x squared over 3. My 3's cancel. I have the square root of x squared, which is x. So this relationship is indeed an inverse function. So now I would like you to try. You have f of x, you need to find the inverse, and then you need to verify that they are functions. So try that one on your own. We will finish the word problems on the back in class tomorrow. Thanks, have a good day.